Welcome back to the Travel Forward stage for the one of our last three sessions for today. Now we're going to turn our attention to the airline industry, and I'm delighted to, in a minute, hand over to John Strickland, who is moderating the next panel session. Aviation is critical to the global economy. It supports the trade, the tourism, and the business sectors. In this session, you will learn more about the challenges and the opportunities facing the industry's decarbonization efforts and the emerging technologies helping airports and airlines take immediate steps to meet the demands for a more sustainable industry. John, I would love for you to take over. I know the panel is in very good hands with you. Thanks for being here, gentlemen.
Great, thanks very much. Welcome, ladies and gentlemen. Welcome to you in the room, and welcome to those of you who are watching us online. Hopefully we've got an interesting session for you in the next 45 minutes. I know I have very good speakers with me, and in a moment, one additional person to join us virtually. Welcome to the panel, which is called Building a Sustainable Air Transport Industry and is sponsored by a major industry partner, SITA. We're going to be using Slido today. I think many of you will be familiar with this. We'll be doing a couple of polls, and if you go into Slido and use the hashtag #TravelForward, you'll be able to access that. Do think of questions as we go along, because we're going to have a Q&A, a question and answer session for you a little bit later in about 30 minutes time. So if you have questions that come to mind, don't wait till then. Get them typed up and on the screen, and then I'll come to those at the appropriate moment. We're going to do a couple of Slido polls as well. So in today's webinar, the aim is that we're going to learn a bit about why is sustainability such a pressing issue. I think probably most of us know why that is. What does it mean for our sector? I mean, particularly this week when we have the COP26 meeting taking place in Glasgow. Aviation certainly in the spotlight for possibly the wrong reasons. But what are we doing to improve our environmental credentials, and what more can we do? So we're going to hear from our speakers' experience today, and what are the key technologies that can help us in this process to improve aviation's reputation and reduce its impact on the environment. So before we actually get into the business at hand, we're going to do our first Slido poll right now, and we'd like to find out from you in the audience whereabouts you are from today. So just waiting to see if the Slido poll is going to come up. And then there's some options that you can select to tell us where you're from. Are we going to get that Slido poll coming up? It's just coming. Bear with us. There you go. So if you just like to click now whereabouts you're from, it looks like some of you may have done this already. Just give you a few seconds more. Don't be shy. There's nothing that you have to reveal about yourself in telling us where you work. Numbers creeping up. We'll give it a bit longer. It's becoming more diverse by the minute, I think. Okay, we may get a couple more. Interesting to see that IT providers in terms of definition are the biggest. That's helpful given that we are a tech session. Other is a bit of a mystery. We don't know who we're listening to or who's listening to us there. Ground handlers very important because a big part of the actual value chain in aviation delivery. Government, well, they could be good or bad for this industry, so good to know that some government people are actively involved in this, and of course media giving coverage on this. Perhaps surprising how few airlines we've got present today, and airports as well, but very minimal on those points. So anyway, we've got an idea. It's going to help all of us to steer our thoughts to best meet your needs as the audience today. So now I'd like to actually introduce the speakers we're going to be talking with today. First of all, to my left, I'd like to welcome Jan Cabaret. Jan is VP Strategy, Product and Marketing, SITA for Aircraft. So Jan, welcome to you.
Thank you.
I know you've come over especially today, flown in from France to meet us today, so glad you managed to make it here to Excel. And to the left of Jan, we have Mark Walton Hayfield. He is Director at Envision Digital, a major technology partner of multiple sectors in this challenge. So Mark, welcome to you. I believe you've come down from the UK Midlands today.
Yeah, thank you.
Welcome. And online, hopefully we're getting back on screen, joining us virtually, we have our airline representative today, who is Moritz Schmeider, Ops Efficiency Manager of Condor Airlines. So welcome to you, Moritz. I just can't see you on the screen.
Good afternoon, Tom.
There you
Thank
go.
you.
Where are you speaking to us from today, Moritz? Are you in Frankfurt?
Yeah, absolutely.
Good to see you. Well, thanks for joining us virtually.
Thank you.
Make sure we keep that technology working to keep you with us for the next 40 minutes or so. Well, of course, it goes without saying we've been experiencing the pandemic for nearly 2 years now, and it's affected all of us in humanity in every aspect of life, but the air transport industry has been massively affected. One positive thing, if we can say anything positive, possibly, is that the pandemic has really acted as a catalyst to speed up change with regard to sustainability and the airline business's credentials. That really has to happen because we've had the recent IPCC report, the Intergovernmental Panel on Climate Change, and not surprisingly, that report makes pretty scary reading. It talks about the likelihood of temperature rises exceeding 1.5 degrees, which was what was agreed at the Paris Climate Change agreement back in 2015, unless we do something to reduce emissions. And as I mentioned, aviation is one of the industries that's finding it hardest to do that. If we don't reduce the temperature increase to this possibly manageable level, then we face some significant climate changes, not least extreme weather conditions, and some of those not only have the effect of being influenced by aviation, but they have an effect rather on aviation. You know, the IPCC says, for example, we can experience much more occasions of greater precipitation and experiences of things such as intense tropical cyclones. Now, looking at aircraft turbulence alone, these are major factors which affect safety, comfort and efficiency of operation for airlines. Now, aviation, of course, is very much in the spotlight for the wrong reasons right now with climate change, and depending on how you measure it, we hear that aviation contributes at least 2% to global CO2 emissions, or as much as 3.5% of emissions if we factor in non-carbon emissions as well. So although that seems quite low, and I must admit I was one of those who in the past was quite defensive about aviation, saying, well, we're not really doing much, it is expected to grow dramatically, partly because aviation itself is going to grow, partly because we can't easily decarbonize while we're using essentially still carbon-based fossil fuels, and partly because other sectors can actually decarbonize much more quickly than we can, so our relative share of any emissions that are produced is going to be larger. So we really have to do something about this. So I'm going to turn now to ask our speakers really the important questions about what can we do. And Jan, coming first of all to you, can you tell us, in your view, when and how can the industry realistically reduce carbon emissions today, and what would you say are the biggest obstacles it faces in doing so?
Sure. Well, I guess the when, you covered it in your introduction, right? The when is now, or some would argue that the when was yesterday, but okay, so that's now, right? And maybe even before talking about the how, maybe I'll talk about the who. We've got quite a few people that have to actually do something to come to meaningful results, right? And obviously the things that come in mind are the aircraft manufacturers, the sustainable fuel, and this, let's say, the obvious players. Now, there are all the type of players, and I've got three specific in mind, which are the airlines, the airports, and the air traffic control, who are like three players, three types of bodies that actually need to do something together so that we can come to meaningful results. And if we think about the how, here there's also a sequencing. What comes to mind is very often that we start thinking about electric aircraft or hydrogen aircraft and so on. That's obviously solutions for the long term. What's quite important is to phase and realize that there are things that can be done in the short term, as well as in the midterm, before we engage into more long-term solutions. And the how is a mix, and obviously the idea is not necessarily to go deep into technology, right? But there is a mix of deep, let's say, modern technologies and let's say collaboration techniques, right? So typically on the technology side, we can now use data science and machine learning to actually change the way we use the airspace, how we optimize aircraft movement. And that's really, let's say, deep new technology that becomes available now and that we can make available right now to airlines, air traffic control, and airports. And there are other things that actually don't really relate to, let's say, new tech, right? But which are more around collaboration. How do you make sure that the different bodies collaborate with each other? And here I'm really talking about the airports, the airlines, and the air traffic control. Meaning in the Slido we had people from government. I'll take typically that air traffic control bodies are from government very often, and they have a huge role to play in the way we can optimize utilization of aircraft, of airspace, and lead to significant results. And here now we really come to potentially two-digit numbers in terms of reduction of emissions, right? So that's very important. And the last part of the question, which was around the main difficulties, right? What's the difficulty there? Well, let's say the aviation industry has been known to be a slow adopter of new technology. And that's one first barrier, right? That's one thing that we actually need to solve. And that's actually where COVID did help. That you mentioned that as well. We, as an IT provider of the industry, and there were quite a few other IT providers there in the room, actually probably saw what we saw at CETA, which is a lot of those airport, airline, and air traffic control changing the way they want to use technology. And so that's the main barrier, but we can see a shift in there. And I guess the other difficulty, the main difficulty, and I'll stop there, is around the fact that it's not a case where only one player can make a difference. It only works if everybody does it together. It looks like a cliche, but actually that's very true in our industry. There's no point in having super efficient aircraft if you actually use them super inefficiently when they are on the ground or in the sky, right? So the main barrier is also how do we make that ecosystem coexist and work together. So that's the two main difficulties.
Absolutely. So as you said, we needed to start yesterday. We still have a lot of challenges. We've got to work together, but at least we have technology to allow us to do that. Thanks very much, Jan. Moritz, coming to you. I mean, possibly the biggest contributor to the... My microphone's just gone off. Yes, back on. Yeah, Moritz, I think airlines are the biggest contributor, inevitably, to the challenge within the aviation sector as a whole, because you're out there flying every day, producing emissions. What would you say are the biggest challenges for you, Condor, as an airline, in dealing with this challenge to reduce emissions and deal with the problem of climate change?
Yeah, thank you. Fulfilled yet, and there are many frictions in between the airlines on the one hand and the different stakeholders of the system, air traffic on the other side.
Yeah, and I think, Moritz, that's perhaps a major point, isn't it? Because single European sky that's been going on, I think, for decades, and we still don't have a single European sky. And perhaps one thing COVID has shown is when less planes are flying, planes can fly more directly. We haven't had all this circling around at airports like Heathrow. And the technology on aircraft already permits much more efficient routings, doesn't it? So we have some way to go on that. Let's come to you in the audience now and just to ask you to take part in our first Slido poll. And we're going to ask you a very simple question. What do you actually feel for you is your biggest challenge to climate change? if you could just now take part in the Slido poll when it comes up, and let's get some more flavour, test for water with yourselves on your thinking. So go ahead and give us some of your thoughts right now. Don't be shy. First one's a good one. Give you a couple more moments. Okay, well, the screen is full. Indeed, it's still building up. Gentlemen on the panel and virtually, any surprises in this? We're getting quite a lot of diverse answers. Certainly one that mirrored what a couple of you have said about collaboration. What are your thoughts? Mark, do you want to come in on this?
Yeah, sure. I mean, there's certainly a lot of comments here in terms of how governments, people and organisations can make a change in the right direction, a step in the right direction. I think building on the points that were made earlier by Jan and Moritz, the time is now, there's lots of things we can do, and the combination of technology and data and using that for the good of sustainability is critical to move forwards with. So I think it's how we pull all of that together in an ecosystem around the value chain of an airline, holidaymakers, and the airport as well.
And Jan, you made a point about collaboration and touched on governments. Somebody put the comment, well, they've got it there, the futility of my personal effort when governments and corporations continue to pollute. Governments are one of the biggest challenges, aren't they, I think, for our sector?
Well, I think they are a challenge and they are the opportunity, right? So, and I think you alluded to the single European sky, right?
Yes.
And obviously today, when you work on an ATC, right, your air traffic control, somehow the aircraft just come as a surprise, right? They appear on your screen like you need to know, and it sounds crazy, right? Like in 2021, we don't have the technology to actually say, okay, that's consider the sky as a system and make sure we can optimize it, right? And that's actually coming, right? And yes, I might be too optimistic here, but I think we are at the point where actually we can see that tension coming around governments and being able to exchange information so that we can optimize those movements, right? So, and maybe I would react quickly to the cost one. I think we always tend to see at first glance that sustainability in aviation is about new aircraft, like Maurice was saying. That's true, but it's not the only thing we can do, right? And actually, we don't talk about rocket science. We actually don't throw anything in the sky here. We just try to actually optimize with existing technologies. And quite a few things we can do today lead to result. And we don't talk about billions of investment, right? And I think that's also, yes, it might be little, but no, we need to start somewhere, right? And I don't think cost is a barrier to anything we can start doing right now.
Absolutely. Yeah. Maurice, do you want to come in? Any reflections from you on what we're seeing here from the audience?
I just want to add that it is not the single point to change the whole system. It's a couple of different screws to drive. Let's say it like this. I mean, if you change a little bit in the ATM environment, a little bit in the development of new aircraft, a little bit in IT and ground operations, you will get at the end a big solution for the whole system.
No, absolutely. It adds up together. Mark, turning to you now, you're from Envision Digital, and of course you are a net zero carbon technology partner for quite a number of industries outside of aviation. are there some examples which may be of interest to the audience here that you see amongst your customers in other sectors where they've really been trying with success to either improve energy efficiency or tackle climate change, maybe use buildings in a smart way? I'm thinking maybe of ports, airports, for example.
Yeah, of course, John. Yeah, so I mean, just to set a little bit of a scene, really, we've talked about optimization a bit, we've talked about data a little bit as well. And the way we see it is there's probably three types of optimization that are really important for these asset-intensive organizations, such as airports and airlines. One starts with the energy. So the more you can optimize the energy usage, and reduce the usage, and improve when it's used and how it's used, the better it will be all round. The second part is really the machine optimization. So with more autonomous vehicles coming in and around a sort of airport ecosystem, more automation, more electrification of all of the things that are needed on the ground to support an aircraft, the more that we can optimize that energy usage as well as the machine usage. And the third bit is the system optimization. So optimizing all systems and processes to make good use of that excess energy that is made available. And the way we see that pulling together, a couple of different examples, I guess, I would bring to mind. One comes from our very own operations at Envision, where we run a racing team, Envision Racing. And, you know, essentially every weekend, it doesn't sound very sustainable, but we in race season, we go from country to country, performing on racetracks with electric vehicles. Now, what those vehicles are doing is simulations on the ground, weeks in advance of that actual race, months in advance of that race. They never get to see the race circuit until they turn up for the race weekend. So everything is done in simulation. And then over the course of that race weekend, everything will be done in terms of software updates, in terms of mechanical updates, between a team of engineers on site at the race and also back at the HQ at Silverstone. So what we're seeing there in terms of collaboration is two different groups of people crunching data, processing data, all with the aim of optimizing that race vehicle for the track it's going to race around and for the driver that's driving it. So what's really important in a Formula E racing car is optimizing that energy usage so that you're essentially ending the race with an empty battery, but not before you get to the end of the race line, and optimizing all the different cornering and braking so that as you power down a straight, you're using that excess energy that you've built up in your battery to make those maneuvers around the corners. And this is, you know, essentially what we're doing in our own business. And using it as an R&D facility for both electric vehicle batteries and things like forecasting of weather and energy usage. But coming on to some real client examples, Port of Singapore embarked on a journey with us probably about 3 years ago now. It continues to grow on that journey. And along those themes of optimization that I mentioned earlier, energy, machine and systems, all of those facets are being dealt with in parallel together with different initiatives making that happen. So a key metric for the Port of Singapore is how many 20-foot equivalent units they can move around the port. You know, it's a $3 billion business, if not more, moving something like 80, 90 million 20-foot equivalent units every year. So the more throughput they can get of those units, whether they're refrigerated units or not refrigerated units, the more they can optimize the cranes, the AGVs, you know, the autonomous guided vehicles, which move around the port, the more they can optimize the people, the refrigeration units and all of that, the more that they can do things like peak shaving, they can sort of optimize where that energy is being used and how it's being used. And then with the introduction of solar panels and battery storage at site, there's way more flexibility in how they can generate energy, use energy, and store energy for future usage. So that's a couple of examples. Hopefully that's interesting.
And I was just thinking there as you spoke, Mark, I mean, we hear currently there are problems in logistics globally with ports. I would imagine Singapore must be able to better deal with some of those challenges if they're employing this kind of technology, and indeed technology being really the root of all this. Crunching all that data wasn't possible even maybe a few years ago.
Yeah, I mean, I think some of the port sort of issues are sort of due to backlogs of traffic coming into and out of ports. But essentially where we're trying to add value, and I think that's a key point, it's about adding value rather than focusing on cost. There will be some costs, but it's how you measure and increment the value across that value chain. Where we're adding that value is in the optimization and the energy reduction across that port operation, which is very similar in a lot of ways to an airport operation.
Absolutely.
I mean, just by the fact that we can now turn off diesel generators on ships, because we can power them from electricity generated behind the meter on the shore, so that we don't have to expend ship's energy on electricity, lighting, and those kinds of things on that ship. It adds a lot of flexibility to how that energy is used.
Absolutely. And on that point, Jan, I mean, you mentioned earlier about aviation being a relatively late adopter of technology, and what we were hearing there from Mark just shows how important it is, and we are in the digital age. What's your take on this about how technology can help to improve credentials in terms of climate change delivery? Do you echo some of the things we've been hearing from Mark?
Yeah, definitely. And I think what I like there is that actually the technology pieces are coming together, right? Mm-hmm. So and it indeed very often comes to how do we optimize the use of resources, how do we use the excess energy, and we see already plenty of examples which indeed couldn't be seen as small, but actually have an impact, right? I mean, an example that comes to mind, which is in the aviation domain, is an aircraft tire manufacturer with whom we work. So we provide that manufacturer more information in terms of aircraft movement, landing conditions, whether the tarmac was dry or not, the temperature of the tarmac, so that they actually have we can model how fast the tires are worn and when they can be changed. So ultimately what we're doing is we're optimizing the usage of one resource, which is that tire, and we only replace it when it's actually needed. And to do that, it's about collecting data, crossing data from multiple sources, and making sure that data feeds algorithm so that we can plan the way tires are getting worn, right? So that part is really there, right? Those elements of technology are actually present in the world that we're living in today.
Excellent. And thinking of operational processes as well, asking Moritz first and then maybe get you back again. What about the actual process of flight, Moritz, operating aircraft? How much technology is coming in there? I know we're having more connected aircraft, aren't we, in a way that we didn't in the past. Is that a really important part of this, would you say?
Yeah, absolutely right. The connectivity and the availability of data gives us many opportunities for greener flying. To give you an example, if I have the actual tail-specific performance modules of an aircraft, if I know, I mean, by using an aircraft over time, it weakens in its performance, of course. And if I know the exact numbers and if I know the actual weather conditions, the exact temperature throughout the different flight levels, I can optimize my climb path or the cruise path of an aircraft. Additionally, of course, the descent, and to come to the I know exactly by historical data, if I know where I'm gonna be parked with my aircraft, I know which exit of the runway is the most economic to reach the terminal parking position as fast as possible. And if I get a prediction by external numbers when I have to shut down my second engine to perform a single engine taxi to the gate, this of course brings a huge saving potential, and that's where we use the connected aircraft and the free available data.
Just going to ask you another question in a moment, Moritz. Just a reminder to you and the audience, you've got your chance to ask some questions to these gentlemen in a moment. So just while I ask another question to Moritz, please type away and put some questions up to us, and we'll come back to you. Moritz, I wanted just to ask you, while the audience is reflecting on that, what about operational issues in terms of aircraft performance, how you go from takeoff to cruise altitude, the issue I mentioned at the beginning, an immediate climate issue like increasing incidences of turbulence. Are you starting to use technology to improve efficiency in that way?
Totally right. Yes. Weather data availability is given inside the flight deck, of course, by using weather radars for decades. But what's new to us is that you get, for example, infrared data where you see exactly where's the thunderstorm building up, and you can circumnavigate by using modern software and as well connectivity. So it's not just the reduction in fuel burn, but it's also a increase in flight safety.
And how does that dovetail with some of the work that CETA is doing, Jan? Are you involved in some aspects of that technology?
Yeah, well, actually, we're working together with Condor on this, and I think maybe the message I'll pass is actually we're not talking about things that we want to do. We're talking about things that we are doing today, right? So, when you're not an expert, and I'm not right in deep aircraft performance, but no, you tend to think that every aircraft has the same performance. Okay, it's an A320, it's an A321 with that engine, and these two aircraft are twins, and they will have the same performance. Well, actually, the reality, that's not the case. Each aircraft, even with the same engine, the same design, and the same structure, has different history. So what we do today is actually we take data from each and every single tail, so aircraft tail, so not aircraft type. We look into its genuine performance, and based on data that we have in terms of the route, the weather data that we see, we will, in real time, provide recommendations in terms of different speeds and altitude so that the pilot can adapt the curve, the path of the flight. And we basically lead to immediate reductions in terms of fuel. And we do that today at climb. We can do that during cruise. And the next big battle, or the big challenge, I would say, is the descent, right? Because the more you can optimize the descent, the less fuel you will consume. As a passenger, you have felt that probably, which is, you go down, and then for a while you stay flat, and then you go down again because air traffic control is not giving you the most optimal route. And this thing, just what's called continuous descent operation, which is optimizing the start of the descent so that the aircraft is going to go down to the airport smoothly without doing any flat level where you will consume fuel. That's the other optimization that we can see, and that's the descent phase. And obviously we have the taxiing, and we talked about that as well here, which is single taxi operation, but also the optimization of aircraft movement on the ground, typically avoiding aircraft to stop. Now, when you're taxiing on the runway, sometimes you will have the two engines started. You run for a while, you think you're going to take off, then you wait for like 5 minutes, two engines, fuel burning for some reason, right? And here we also, that's another challenge to solve, which is how do we optimize aircraft movement on the ground so that they actually never stop? And then you can have single engine taxiing because you don't need to restart the aircraft, right? So actually all these things are super interesting challenges that will lead to reduction of emissions.
And as Moritz was saying before, that all adds up to a significant change when you take these small elements added together.
Correct.
I'm just going to go to the audience. Any of you who would like to ask a question, now is your chance. Just type it in on Slido. I just want to check with the tech people. I've got the Slido screen here with the QR code. Is that the right screen for me? Okay, perfect. So do come out with any questions that you've got while we've got these fine gentlemen with us with their technical knowledge. Got another few minutes for you to put questions forward. I see a couple of people typing away. There is a microphone actually up here if anybody does feel more comfortable actually to come up and ask it rather than using technology. So feel free. Moritz, just while we're waiting for a few questions to come in, how do you see the constraints that Jan was mentioning there that actually impede on doing these optimal things day to day? Are they really a big headache? We know there are air traffic constraints in Europe. We know there are congested airports like, say, Frankfurt or Heathrow where you can't do all these things as you would wish. Can we still make a difference even in that constrained environment?
Yes, absolutely. I mean, it's often by air traffic control. It's constrained not because they want to have constraints for the airlines, for the pilots. It's often because air traffic management system doesn't know the exact needs of the aircraft, of course. And actually, the data will be, and the external data will be loaded into the aircraft, uploaded to the aircraft, and then the decision is made solely by the pilot. And I think for the futures, there should be also a development the other way around. So the view of the pilot is actually, it's not completely not shared with the other stakeholders. So if air traffic control would in future have a chance to see also the needs of the pilots, that would be a great future.
I mean, that point that Jan made about sitting at the end of a runway, both engines running, and then finally you've got a longer wait. If you knew that and could work on it, you could just cut the fuel burn immediately. Mark, do you want to come in with any comments on this? Is it making you reflect more that the industry could do as someone who sees many other industries?
Yeah, no, absolutely. I mean, from our point of view, we manage hundreds of gigawatts of renewable energy, and in order to be doing that, it's very intermittent. Wind and solar are intermittent energy sources, but the way to get around that intermittency and to solve some of the challenges we've been hearing today is to be really good at forecasting what's going to happen next. So when you start to get weather forecasting and power and energy and load forecasting and aircraft movement forecasting, and you get that right, that's when you can make better decisions, better communication, better collaboration, and the whole ecosystem can work towards that overall goal. And I think the more that the value chain is able to sort of drive these improvements and these optimizations with different stakeholders, the better it's going to be. Because you rightly say there's things are being lost because air traffic control's doing their job, the airline's doing their job, the airport's doing its job. But they're not working as one piece together with one set of data. These machines are only going to get more complex. They're only going to get more data coming from them, and it's how we use that data towards the end goal and the end aim that's important.
But when you described about your race teams, all the number crunching that goes on, they don't actually see the racetrack till they arrive there, but a whole load of preparation has been done.
Yeah.
So it's quite incredible, really, the steps forward that we're actually making.
Yeah, when you talk to them, there are somewhere in the region of 40 or 50 software updates happening over the whole of the race weekend. So there's countless engineering updates happening, just like you'd get on an aircraft. But 40 or 50 software updates just based on data is incredible.
And Maurits, again, just thinking about an airport like Heathrow, when a thunderstorm comes and suddenly everything grinds to a halt, and I'm sure then it's really a case of panic's not the right word, but everything's got to be improvised very quickly because there isn't a chance to optimize when you've got aircraft stacking up either to land, to depart, push back from gates, and so on.
Yeah, you're absolutely right, and that's the short time of changes is day-to-day business. I mean, it's usually you don't have that big impact as you had in thunderstorms, as you mentioned, but even if you have that very extreme situation. There is no disadvantage of using the newer technologies. Then you can switch for this specific situation back to the common processes and fly not that efficiently, but there's no disadvantage. But additionally, as mentioned before, using the new technologies, you will have in this case a possibility to fly more safe than without.
Jan, do you want to add something there?
Yeah, I think what we need to see is aviation has been built around safety, and that's the
way. Has
way,
to come before everything.
Yeah, exactly, and that's the way the whole thing has been built for many years, and obviously it has to remain like that, right? So we talk about inefficiencies of air traffic management. Well, it's here for a reason. It's here because when you don't know where the aircraft is really, well, actually, you have to take some level of safety around aircraft separation and so on, right? So the big challenge that will come is around how do I reduce aircraft separation And how do I optimize that, right? So it's not because, no, there's a good reason why we have those waiting patterns and so on, is to ensure passenger safety. And if you project yourself in like 20 years from now, where in 20 years from now, we'll have hundreds of thousands of UAMs or no, unmanned aircraft that are going to fly, whether they have people in it or just Amazon parcels is a different thing. But no, the way we optimize airspace is going to become an absolute.
I mean, that seems a massive challenge. Every time I hear this talk about urban taxis,
yes,
I think, how on earth are we going to do that?
Well, what is sure is that we're not going to be able to manage that with one guy in a tower looking at a radar screen. That's not going to work, right? So anyway, this is going to drive a huge change in the way we manage airspace, right? So I think the aircraft separation, and that's the link to technology, right? Which is when you know more accurately where an aircraft is, its speed, its destination, its weather around it, and how it fits into an overall system, then you can start optimizing, right? And today that doesn't exist because apart from the pilot, that's what Maurice was saying, the pilot knows where he is, he knows its route and its speed and its altitude, but nobody else knows really, right? So actually, absolutely, for as long as you don't provide that info to a higher level of intelligence on the ground, you can't really predict or optimize the airspace as a system, and that's what's going to come in our lifetime, right? That's for sure.
And the aircraft themselves largely can do this. They have the technology on board. It's more of a ground and support equipment.
Exactly. And well, I mean, the challenge of transmitting data to the ground has always been a limiting factor, right? Because you have to know that up to now, the aircraft are connected through a VHF link, right? That link has been here since World War II. Mm-hmm. So obviously now you can start seeing more satellite links and so on. So they are going to change the landscape of connectivity, and then we'll then be able to transmit real-time data that allows real-time decision making. That's what has not existed until now.
Absolutely. Just see a few questions that come up from the audience. I mean, one thing about battery and hydrogen-powered flights, Jan, I mean, I was chairing another panel earlier today. The challenge with those is they are really decades away, aren't they, in terms of large aircraft? We can't use those right now, so we've got to find other solutions. And Moritz, I mean, correct me if I'm wrong, that's the case. In Condor, you can't be using battery or hydrogen-powered aircraft for your current fleet, can you?
Yeah, that's true. I mean, as you mentioned, that's maybe some decades away. Anyhow, we all have to do our best to get it as early as possible. But for the time, there are different ways to gain a lower fuel flow and lower carbon emissions.
And there's another question for you, Maurice, which says, why, there's a lot of talk of partnerships on the panel. So what is stopping airlines sharing their specific emissions data with buyers and suppliers? I don't have enough knowledge to know if that is the case. Do you know anything about that, Maurice? Is it true that that's not shared?
Yeah, I mean, it's true in a way. If you have performance data of an aircraft and you have the exact fuel flow numbers, you can calculate back, of course, the payload on board. So to say it in clear words, if you know the fuel or the CO2 emissions of an aircraft, you can get into the top secret numbers like, for example, passenger numbers or payload.
Great, thanks very much. And there's some other very good questions here about mass market tourism and climate change, which are probably going to have to wait for another day or another panel. We're nearly out of time, so I've just got to ask all of you on the panel, if you could just give me one wrap-up comment each. I just want to ask you all the same question. Mark, if I could start with you, what is the one thing that is going to make the biggest difference for a greener air transport industry, in your view?
Yeah, so I think it's getting started right now, pulling together the different measures that can be undertaken right now, looking and tracking the measurement and usage of energy and energy across and carbon across the estate, looking at the abatement measures that are possible, and driving, if at absolute last resort, if the abatement measures are happening too late, starting to look at the offsets that could happen in that ecosystem and really pulling things together, but being led by data and doing it now.
Great, thanks, Mark. Jan?
Well, it's quite a hard question. I think the point is indeed, and the comment was made in the question around the collaboration. But it sounds like we just ask people to talk to each other. That's not really the message. The message is actually we need to connect different systems that have operated in
Data
silos.
and
Exactly.
information.
And that indeed is going to make a difference. It's not going to remove emissions, that's going to optimize the use of energy, right? And we talked about emissions. There are other things that are typically, condensation trails and so on, which are not emissions, but are still having an impact on the climate, which we can also address. And they're not just about fuel and fuel consumption, right? So I think that's really what I take there, which is break the silos and use existing technology to optimize the use of the energy while we build more efficient aircraft and sustainable fuel, and because that will also come in the decades to come.
So I think breaking down the silos, it's always a challenge, but as you said, it has to happen.
It has to happen.
But data is there, it needs to be shared and used constructively. So the last word to you, Moritz, what is your one snappy answer on the best way forward to a greener industry?
Yeah. It's also collaboration of all the stakeholders. It's working together in the right direction. And of course, this will bring us automatically to, for example, a single European sky.
Short and snappy. Oh, you want to add a quick supplement for a few seconds?
Just one comment. I think what's important as well is to make sure that the public knows about it, right? Because we hear, we have travelers, and there's no point in, there is a point in us doing all this, but there's also a point in making sure that the public knows about it.
The industry is making an effort.
Yes, and that it is good to fly, right? I mean, there are cases where it might not, air flying might not be the right thing to do, and I think this will be regulated overall. But there are things that where you have to fly, and it's important to show that it's not that the industry is just trying to take any profits from it, and we'll see later, right? I think the angle around communication to potential passengers is an important one, which we didn't mention that here, but I think it's important.
Very good point, Jan. Well, thanks to all my speakers today, Jan Cabaret from CETA, Mark from Envision Digital, Moritz Schneider from Condor. It's been great to hear your insights today. A lot more we could have covered. The clock's against us. Thanks to all of you, ladies and gentlemen, for being here in the room and online. Thanks for your questions. I wish you a good rest of day. And if you're staying for further Travel Forward sessions, be back here if you indeed need to exit the theatre in 10 minutes. The next session is at 4:15. Thank you very much indeed.